Hey everyone, welcome to another project video, and in this we will actually see that how we will use the SVM and we will actually hypertune the SVM, or we could say the SVR, the support vector regression, to get actually a good prediction. And this is will be the motto of this our video. And let's get first into why the mouse is so first let's get into our to-do list, that what we have to do. So the first thing that we have to do is that hypertune the wait yeah hypertune hypertune the uh, SVR. Okay, then this is will be our most important thing for today, because we want actually a very good prediction or the best parameter for our SVR. And we will actually search that what is the most important thing that we should change. Okay, what is the most important thing that we have to change that can change in the prediction. Okay, so there are a lot of parameters in the SVR. As you could see here is that we have kernel, we have degree, we have gamma, we have coefficient 0, what it is, then we have tolerance tol, then a C, then epsilon, sorry, shrinking, cache size, verbose, max iter, and all those things. We should know that what this does actually. Okay, without understanding these we cannot move ahead, and we cannot know that what is the most important thing that we should change that can actually make any change in it. Okay, so we were doing, and as I observed in the previous lectures, that we were actually using four, the metric for the valuation. We were using four, the mean squared error, then R2 score, and RMSE, then MAE, the mean absolute error. And I thought, like, why should we use four when we can use two for the better understanding of that. This is the thing that we have to use, and that can tell me that what we have to minimize, whether it is RMSE, R2 score. Okay, R2 score is nothing but it don't tell us, but it tells actually that how our model is well fitted. Okay, this is R2 score tells, and RMSE is root mean squared error. We all know that, and that is the thing. So let's get first into that. What are the parameters that we need to understand? Okay, we need to understand before hyper tuning our SVM, which is a very important thing. Okay, and we have built our pipeline for this also. Okay, that was a good thing. And we have actually did not done most of visualizations for our projects. That we will do, but still we don't need it right now because we are just exploring and seeing that what we need actually. Okay, so first of all, let's come here and linear SVR. Okay, sorry, linear SVR, not SVR but linear SVR. Okay, linear SVR, okay, SVR, linear SVR. Okay, so we have some of parameters which are epsilon, tol, C, loss, fit intercept, scaling, dual, verbose, random state, and max iter. Okay, so let's see what are the parameters that we need to know. Okay, so I have actually given here a command. So what is the parameter of, let's change it, linear SVR? Do explain. Okay, it's doing its work. Okay, let's let linear the scikit-learn implements a linear regression. Okay, it is designed to solve regression problem where the relationship between the input and feature target is linear, unlike the standard SVR class, which is can be previous. Okay. Okay, so we have here, yeah, so we have got our query, the answer of our query. Okay, yeah, yeah. So the first thing that we have epsilon, okay, description. The epsilon parameter defines a margin of tolerance within no penalties given to error. In other words, prediction that falls within the epsilon range of the true value are considered correct. Error within this margin are not penalized. Okay, effect a larger epsilon value result in wider margin, meaning more data points will fall within the margin without incurring incurring a loss. This can lead to a simpler model that might underfit the data. Okay, a smaller epsilon values makes the model more sensitive to errors, potentially leading to overfitting as the model tries to fit more data point exactly. Okay. Use choosing epsilon is often a trade-off between model complexity and tolerance to prediction error. Okay, so this is our first parameter, which is epsilon. Okay, so first we should understand which is the most important parameters that we should consider. Okay, so which is the most important parameter that we should consider uh, in the linear SVR. C parameter. Okay, so C is the most crucial thing. Regularization versus fit. The C parameter controls the trade-off between minimizing and error and controlling the complexity of model. That is regularization. Okay, so that is regularization. High C value with high C model will prioritize minimizing the error, potentially leading to overfitting, especially the data is noisy. Okay, and low noisy value, a low C value increases regularization, which can prevent overfitting by simplifying the model, but it might underfit. Okay, so C is the most important thing, that is regularization actually. Okay, so this regularization parameter, which is C, that is the most important thing that we have to consider. Okay, so right now we are going to change the C parameter. Okay, so C can be 1 to whatever, and let's change the C. Okay, not Appleson, C. Okay, C and C. Okay, C 1.5. Okay, if we see any changes actually, then we will actually change it. Okay, we'll actually change it, and then fitting the model. Okay, R2 score. Okay, so let's check. We should check. Yeah, we could see a tremendous change. Okay, see what we are doing here is that, see, we actually got, a less value. See, the R2 score is -6. Okay, 81, and valid the R2 score in the second SVR is -6.7. Okay, and we should only print it. Wait. Okay, the RMSC is 1.3. Okay, we have actually got reduced. See, it has reduced, it has decreased. That is a good thing. That is a good thing. That is a very good thing, man. We are seeing the changes. That is a very good thing. So the most important thing, okay, from all these parameters, okay, all these parameters which are epsilon, tall, then we have C, loss, epsilon sensitive, fit, intercept, and all those these parameters. The most important parameter is C, which is nothing but the regularization parameter. Okay, C is the regularization parameter, which is the most important thing. Regularization parameter, which we have to actually tuning. Okay, must be tuned. Okay, must be tuned, hyperparameter tuning. So we have to check this parameter, which is C, which is the most important thing that we have to do. Okay, see, I don't even know that which is important. I'm just here and exploring and seeing while recording this video that which is the most important thing. And if you think that, oh man, if is not telling us which is the most important thing to see, I'm just exploring, and I'm just overcoming my fear, just okay, that I am not doing what should I do, but I always waste my time and I don't do the project, which is the most important thing. Because if you are just learning the theory, this won't be make any sense. Because if you don't do the project and if you won't understand the code, then this is not the right way. So from recording all these videos and lectures, I actually make myself accountable. First of all is that accountable or accountability for my own self, for my own. Okay, then I actually explore. Okay, I explore the things in the code for my sake. Okay, and then I also help you to understand. I also help you to understand the concepts which I understand. Okay, as you have seen that I didn't waste my much time in understanding every concept, because I just choose which is the most important thing, which was C, and I just changed its value and we got the result. That is the most important thing. And these one spent 1 hour actually helps me to understand, and it makes me super focused. Okay, it's make me super focused that I only have to do my code. I don't have to do anything else between it. Okay, so that is the thing, which is the most important thing. Okay, now as we seen that the C is the most crucial thing. Okay, we have red tail here. Now overfitting and underfitting, proper tuning of the C parameter is essential for finding the right balance between overfitting and underfitting, which directly impacts the model generalization ability to on unseen data. Yeah, tolerance, error tolerance, while other parameters like epsilon control how errors are treated within a margin. Okay, the C parameter has a broader impact by influencing how strictly the model fits the data outside the margin. Okay, so if we see that how does a linear SVR fits the data. Okay, images. Yeah, it basically what it does is that in linear SVR, what is being done is that we have this, it is the graph. Okay, and suppose that we have this kind of data. Where is my, okay, so we have this kind of data in the linear form. If it's going like this, okay, and we need actually the support vector machine to fit this data. So what it will do is that, wait, yeah, so what it will do actually is that it will fit a data like this. Okay, it will fit a line like this. Okay, this is a line, this is not the linear regression of line. Then another line within the margin like this. Okay, and another like this, and the data point that comes under under this margin. Okay, this whole margin, then these are fitted, these values are fitted, and outside from these the margin, like these values are considered as error. I think it should be considered as error. Okay, so let's see how it does. Yeah, slack variable, minimizing this. So we have this medium. Okay, I'm not logged in, but still we have some of one of the most good. That's where the goal of finding the best fit line accurately predicting the target period while reducing the complexity of to avoid overfitting. To achieve this, and E sensitive, we have got it instead of the hyperparameter defined, which permits some level of deviation between the actual predicted value, creating a balance the complexity of model. Okay. This is this. So we'll explore. Okay, so this is the most important thing, is exploring thing and knowing that what is has been written, not only just going and just writing the 3 lines 4 lines of code and seeing thing. Okay, so we have been given some code here also that will help us to understand how it is actually implements, yeah, fitting in the SVR model. So yeah, first of all, it has been scaled first. Okay, then it has been transferred. Yeah, we have seen. Okay, scaling the data, we have SVR. We actually need to do the linear SVR, not. So this is the fitting, and we could yeah man, we could also check this also, by the way. We can do this. Yeah, that's a good thing. Study time marks. Okay, good. That's a good thing. We should appreciate it. Okay, we cannot sign it, but yeah, still, but okay. So, as we seen, what is the most important thing is C parameter. That is a good thing. Okay. Now, moving ahead, these I think would be called errors. Okay. So, maximum margin hyperplane is this, and this is a maximum margin hyperplane, and these are the support vectors. Man, this is for classification. Okay, sorry, we want actually for the regression problem. Okay, so minimizing 1/2, it's norm of W. Okay, constraint. Okay, good. Moving ahead. Okay, hyperplane. Okay, assuming that the equation of hyperplane would be this, and then the equation boundary would be okay, this. Okay, this. Okay, yeah. So what this actually tell is that the equation, there will be this. So away from this line, away from this margin, okay, decision boundaries, like we would actually call it, is like decision boundaries. So if the point is, or the data point is away from this decision point, then we can call this an error, or we could say that this is what is the thing that we call it. So our meaning of him is to decide its boundary at a distance from the origin hyperplane, as we are going to take those points that are within the decision boundary. Yeah, we cannot appreciate it, but yeah, there are a lot of things that we have to read that can make us pretty well to understand. Error tolerance C. Okay, practical consideration, cross validation. When working with linear estimate, common to use cross validation to tune the C parameter, ensuring that the chosen value leads to best generalization performance over validation. While other parameters like epsilon and tau are also important, the C parameter is typical most crucial because it has most significant impact on model's bias variance trade-off overall. Okay, so after C in linear SVR, which is the most important? After C, we should know there would be tau and epsilon. Yeah, man, yeah. Epsilon is considered okay. After C parameter, most important parameter to consider epsilon. Why epsilon is important? Okay. This we have this thing, we have this thing, we have this thing. Okay. So what are the values for C in linear SVR? We should choose. Okay, from 0 or from 0.1 or from which, typically range from 0 1. Okay 0 0 1 to 0 0.1 0 1 0 1. Okay, got it. Grid search. Okay, grid search, linear SMV. Okay, cross validation. Okay, domain knowledge. Okay. So the things that we are going to do. Okay, the first thing is grid search, then cross validation with grid search. Okay, So that would be the best for the finding of the model. Okay. Man, wait. If I search linear regression of sklearn, then what do we let's see from it also. So we don't have much parameter in it, but still okay. Yeah. Okay. So the things that we have to do is first what we did was is that first building a pipeline with different values of C, then doing the what it was grid search okay, then then doing the cross validation. Okay, cross validation. Yeah, this will be a most important thing. So now we are actually going to build a function, okay, or sorry, a loop in which we'll be doing all those scores and all those things. So the most important thing that we have to do is to write C, okay, the parameter C from 0.001 or it's 001. Okay, wait, let me see. From score from 001. Okay, that's good. 01, 001, 0.1, then we have 1, 10, 100 and 1000. Okay, we have these values. Okay, we have these values from 1000, and we can do the grid search also, but not right now. We'll be just performing in the our from. So for C in C, we're building a pipeline. Okay, let's copy paste it, man. Why should I waste my time? Let's copy paste it where we had our pipeline. This. So we'll not be naming it because we don't need to name it actually, but SVR pipeline. Okay, and for C we are going to just write C. Okay, then SVR pipeline dot fit xtrain and ytrain. Okay, then getting our prediction, so which is nothing but ypred prediction, or SVR prediction will be SVR pipeline dot predict on x or on our validation set. Okay, then getting our MSC. Okay, so should we consider, okay, wait, when what does R2 score tells actually, and what does R2 score tells us, and should we consider it if we are using the RMSC? Let's ask GPT, what does R2 school tell? The R2 school also knows the coefficient of determination. It is okay. Yes, as we have said that it how well indicates how well the regression prediction approximate the actual data points. It represents the proportion of variance in the dependent variable, which is target variable, that is predictable from the independent of R2 score equal to 1. The model perfectly predict the variable target score with all the data points lying exactly on the regression line. Okay, simple mean based, indicating that the prediction are of more than if just need to mean. Okay, if R2 score is less than 0, then it's which, okay. So they consider if you are using RMSC, root mean square error, R2 scores of different value, both can be useful depending on what you want. Understand about your model. The first thing is RMSC, absolute error measures. RMSC gives you an absolute measure of the average prediction error in the units of target variable. It tells it tells how far on average the model prediction are from the actual value. Yes. Scale sensitivity. RMSC is sensitive to scale of the target variable. It is not normalized, so it can be hard to compare across different data set unless the target variable is scaled in the same. Okay. Yeah. Relative performance measure. R2 will tell how well the model explain the variance in the target variable relative to the variance explained by the simple mean based model. Okay, gives a sense of model explanatory power. Normalized R2 score is a dimensionless measure, making it easier to compare. R2 score is dimensionless, making it easier to compare across different model of data set. Okay. When to use both? Complementary insight. Using both together can provide complementary insight. RMC give an idea of magnitude of prediction error. Yeah, that's good. While R2 can tell you how your model captures the underlying data structures. Okay. So mainly the thing is that you should consider both, and when evaluating the regression model, RMSE provide an absolute measure of prediction accuracy, while R2 score gives a relative measure of how well the model. Okay. So I've got it that R2 score mainly tells that how our model is well fitted. Okay, well fitted. Okay, and RMSE tells us that how far the data points are from the thing. Okay, so that can be a good thing. We're using both. Okay, so our R2 score, our wait man, I can do this also. Can I do it? Yes, I can definitely do it. Okay, why should I waste my time when I have all these things? Okay, so SVR, we should use the F. Okay, F, this thing, then this thing. Could we use wait? Okay, we should consider. Okay. Wait, I got this. What if we want then R2, R, let it just R2. Okay, just copy paste it from here, and we don't have any SVM, so SVM y pred. Okay, then RMSC would be nothing but simple is like this, np dot r square, this, copy paste, y y y pred. Okay, that's a good thing. Then here we won't be using this thing. We'll be using instead RMSC dot 2f. Okay, how do we use it this man? How, like, yes, we use like this. Okay, I think like this. Okay, if we get error, then we'll consider it. See, I don't know much of things like this is used, in most of cases, but I don't use it actually. But still, if I'm using it, let's see it. If we get an error, we'll be asking the GPT. We have our, to 2f. Okay, let's see if we get an error. Yeah, I thought we would get. How do we use it this match? We were right, man. We were right. Still, we are getting error. Oof. Oh yeah, I haven't wrote that here. So will we still get any error? Yeah, we got it. SVMY. Sorry, it's SVR. Oh yeah, SVR. It's not SVM. SVR validation. Okay, we can use it. This. Yeah. When C is actually wait. Print C equal to C just. Okay. C equal to 0.001 SVR validation R2 score minus 6.84. Still 84 from when we were 1. It's 6.81. That's a good thing. Yeah, man, when our value is increasing, the C is increasing from 1000. Okay, we are getting a good value. So could we, move to 10,000 also? Like it will be costly or what? I don't know, but still let's move it to 10,000 or 1 lakh. Let's see. If it's costly, man, then we won't do it, but still. Number of lib linear fail to converge, increase the number of iteration. Okay, max iter. Okay, pipeline. Wait, I should do it like this also. That will be a good thing. And the max iter will be 20,000. 20,000. That is a good thing. Okay. No, we did not get that same error. Okay, so our RMSC is around 68526. Should we, should we increase if we are getting this? Okay. Okay, so uh should we increase the value of C if we are getting this value? Man, see, like if our, we need to actually work with the data, because it doesn't matter that I'm asking GPT, it will tell by its own, like what does it know, but still I need to understand the data what it is fitting actual. So I need some visualizations for, getting that how well that data is fitting. But still, should we increase it if we're getting this value? R2 score, consider the following. R2 score 0.3, RMSE consider C. Okay. Provide an absolute. Okay. Average score target. Okay. So evaluation. Okay, man. Okay. So as in the linear as well, man. Like yeah. So effect increasing will reduce the regression effect, making a model fit the training more closely. This can potentially reduce the training error and improve the fit, possibly leading to higher errors and lower MC validation risk. A higher value increase the risk of overfitting. Yeah, that is the great thing. See, what we are actually doing is that if we increase the value of C, okay. So if our C is lower, okay, if our C is lower, then this will be our the SVM, the SVM value, sorry, the SVM decision boundary. Okay, if our have a lower, sorry, this is a lower, wait man, if the value of C, if the value of C is lower in linear SVR, then then the decision, then the what I would say, margin then the margin will be narrower or what? Under the trade-off window. Okay. Narrower margin is the okay. Okay, so graph of visualization having lower and higher C, say in linear SVR, visualization of linear SVR, okay, uh, effect on the decision boundary. Lower C, higher C, yeah, man. As I said, actually, that lower C means the graph, or no, not the graph, but this will be, wider. This will be wider. But if we have if we have higher C, okay, if we have higher C, then this will be narrower. This will be narrower and will be, actually taking much data points, taking minimum data points. So our error will be low also, okay. And if I have our this condition, then this can lead to overfitting because we don't have much data trained on, okay. It doesn't only mean that lowering the MSC, okay, MSC always means to a very good model, because sometimes it can happen that we won't get a good, I would say, good prediction, because it can be overfit also, okay, can be overfitted also. So that is not the case that we only have to minimize the thing, but getting, the graph is the important thing. So 0.1, okay, so we should actually consider from, not from 0 1, but from where we are getting, the this lower point, okay. So we should first remove from 10, okay, from 10 we should remove it because we won't be using this thing, okay. See, this is our parameters, and if we talk about the grid search, this is our grid search which is telling us to improve this parameter grid. Then we would have C, then we would have how can we perform cross validation in linear SVR, okay, important thing to perform in cycle and use, okay, model linear SVR, okay, model scores -1, NPS QRT -1 scores. So CV5 scoring negative, mean squared error epsilon 0.1. What does it actually do? Okay, so we have our scores, RMSC scores, why it is negative, okay, I got it. Then we have convert negative MSC to positive RMSC, okay, good, minus. Then we have using cross validate X and Y scoring negative return this, okay. Okay, cross validation RMSC a score mean RMSC cross val scores quick and straightforward, ideal for basics. Cross validation to get performance scores. Cross validate more detailed. Okay, so quick and straight in the cross val score, we will get quick and straightforward, ideal for basic cross validation to get performance score. Cross validate more detailed and allow you to obtain additional matrices and control over output, okay. Performance linear across different folds, and okay, so we have got that we will have our folds, okay, and in this we will actually build this thing, okay. So if we improve it to, if it is 10,000, could we move to 2,000, okay, wait, 20,000, then 20,000, then 50,000, then 1 lakh, or I would say 100k, 100k, okay, then 500k, 500k. Let's see, man, what there is not much of difference. Okay, there's not much of difference here, so we won't be, doesn't mean that always having a good model. Okay, so this we don't have, you know, much difference in it. See here we have actually got, so this won't make any sense because these are very huge values that doesn't even make sense. Okay, from here we have, okay, for the 1 lakh or 100,000 also we are getting, you know, here we have 451, here we have 509, so there is a huge difference. Okay, and you could see that I think C equal to 10,000 is the sweet spot by my own, like from finding by my seeing by myself and experimenting. I can say that the 10,000 is the sweet spot. But let's do the grid search, okay, to get the best values. Okay, epsilon man, epsilon. Okay, yeah, epsilon we could use it, scoring it if this is okay. So let's copy paste it, but we won't do it copy pasting it, but doing the cross validation, sorry, grid search. So this is our grid search. Let's write it grid search, and in the grid search from which man, from model selection, import grid search CV. Okay, so C, okay, in the, so we're just copy pasting it, and just put more values from and 0 0. Let's see we have to see. Okay, see if I give more parameters to it, then it will be taking much computational power. Okay, which I don't need it, it will take much time, but still I will give these values only. Okay, and it will, if it is find our sweet spot, then yeah, that's a good thing, that's a very good thing. So yeah, that is a thing, that if epsilon, yeah, we could say this is thing. Now moving ahead, what we have, we had our grid, not getting any use of epsilon. So what we'll do is that let's tell it you should go home and param grid equal to C. Okay, it will be 100, 1000, 10,000. Then how it is giving, man? See, I'm not just copy pasting all those things, but getting the values. So from the 5, there's this much. Let's print this much, but the max iter will be 10,000. We have max iter is 10,000. 10,000. Is it in a list? I think it is in a list. Yeah, it is in a list. 10,000. Grid search linear SVR param grid and verbose CV equal to 5. Cross validation is it? I think verbose. So linear SVR. Yeah, I got it. I got it, man. I got it. I got it. Cancel the run. Okay. Cancel the run, man. Stop execution. Ooh, boom. Let's see. Let's see. I think this should run. Man. This should run. Come on. Oh, wait. What? Oh, yes. Yes, I forgot. We have got an error successfully. If it cannot clone object, you should provide an instance of SQL and estimator instead of a class. Oh yeah, we should give the class. My mistake. We should give this. Okay, it's my mistake. Fitting 5-fold of each 6 candidates, 30 fits. Oh man, should I increase the number? Are you sure? Okay. We are canceling the run and we are totaling 30 fits. Okay. Let's see 20,000 if it doesn't work. Man, literally, you're telling me to do this. Okay, cancel run. We are going for 1 lakh. Let's see. Fitting 5 folds of each 6 candidates, totaling 30 fits. Let's see it. What happens, what does not. If it won't make, I don't think so that. Oh, holy. Yeah. So if I copy paste this, okay, and if I shut this mouth up, and if I just paste it here, and let's see what's its result, and if it doesn't give us the result, and if this cells give us the result, then I will suicide. I'm committing suicide. We are still getting that error. Okay, no problem. Okay, so we are still getting that error, and for this we have actually hyper tuned our SVR. Now we have to find the best fit model. Okay, so that is it for this video, and thanks for watching till right now. Like, if you find this video valuable, or if you like this video, let me know in the comment and suggest me that if there is any suggestion for doing all those things in a good way. So write down in the comment, and thanks for watching till right now. Have a great day, and if you haven't joined our Discord, do join our Discord. Bye bye.